You can go from 0 to 80%, as you said, very fast, from 80 to 90, maybe a bit slower, but still doable. But what really matters, it's how you go from 99.9 into the further digits. Because if you multiply this percentage, industry operates 24/7 every day. We are sleeping and the production is not. So if you actually multiply these failure rates, it might destroy your ROIs.
This is Melanie.
And this is Christian.
You're listening to Follow the Gradient, the weekly podcast with actionable insights about how to build a business while staying sane.
Welcome back to another episode of Follow the Gradient. We have all seen these videos, humanoid robots doing backflips, making coffee, or dancing to pop songs. And it's easy to get swept up in the cool factor of all of this. But there is a massive gap between a viral data collection puppet and a machine that actually provides industrial ROI. And in the world of robotics, your time isn't just measured in code, it's measured in reliability, physical safety, and the dull, dirty, and dangerous tasks that humans no longer want to do. In the next 50 minutes, we sit down with Lukas Ziegler, one of the most influential voices in global robotics. Lukas didn't start as an influencer. He started by coding in robotics. And today, his insights reach over 100 million people a year. And his work has been shared by everyone from corporate boardrooms over to Elon Musk. We dive deep into why wheeled robots deliver 80% of functionality at 20% of the cost, and why humanoids are still winning the funding war, why 95% success in the lab is a failure in the warehouse, and how to survive this reliability cliff, and how to find the specific boring problems that customers are actually desperate for to pay. Before we jump in, please subscribe and follow to our show. It's the best way to ensure we can keep bringing you the builders, founders, and investors you want to hear from. And for our newsletter and data points from our intelligence unit, head over to followthegradient.io. And now, enjoy the conversation.
Lukas, so you started by programming universal robots in Poland, and now you're a venture partner and the global voice for the industry. This is also how we heard about you. What was the specific moment you realized that being the person explaining the robot was more impactful than being the person actually coding the robot?
Okay. So yeah, I think right now everyone expects like a specific story about it. I must admit it was very random. So I started as a software developer for robotics companies, as you mentioned, Universal Robots, and I was doing it for 2 years. But after 2 years, I realized that probably I won't be one of the best coders in robotics industry, and I decided obviously to pivot into more commercial and business development roles. And I was developing the collaborative market, the collaborative robot market and AMR market here in Poland. And then I moved to Germany. I was working for Energy Robotics, a Series A startups, and we were deploying the robot dogs all around the world, in US, in Abu Dhabi, in Australia even. And we made sure that the dangerous tasks are not handled by people, but actually by robots. So I just loved the mission. And also in the meantime, I was just obsessed about robotics. So I was just posting about it on Twitter or LinkedIn. I didn't even consider it as a side hustle. I just liked doing it. And after 2 years of consequence and pushing the robotics news, I decided to spin it off into my own kind of media company. So right now I'm the influencer, but I must admit that I never planned to be one. So it was very random for me to become one of these influencers or evangelists, but I must say that I enjoy traveling all around the world, talking to the coolest founders and just learning the story of the best robotic startups and companies over the globe. So
Yeah, and I think it's also like one of the success factors of doing such a thing, because if you just do it for the fame, so to say, it won't like last long. But because you're curious about it and naturally curious about it, I think that also kept you really digging for the interesting stuff that then lots of people actually wanted to hear about.
yeah, I agree. I never wanted to do it for the fame and fortunes, and I always just wanted to do it for the pure curiosity of the industry. And obviously there was a couple of factors, like when I started, the robotics industry started to grow suddenly because the AI boom was so huge that suddenly people realized, hey, you can just apply AI also to the machines, right? So they can think better, so they can be more autonomous, they can be more dexterous, and suddenly we are probably in one of the hottest, if not the hottest markets in the world right now.
Yeah, very much. And diving directly into this market, we have so many questions that we would like to ask and discuss with you. You've pioneered a signature contrarian take. So the 80-20 rule, stating that wheeled robots deliver 80% of humanoid functionality at roughly 20% of the cost. In a world where Figure AI is sitting on a 39 billion valuation and Aptronic just closed a massive 935 million Series A, why is the cool factor, so to say, of two legs still winning the funding war over the efficiency of four wheels?
Okay, very good question. First of all, I think there is a big promise and a big bet in the venture capital industry to create sort of a general purpose robot. A jack of all trades, a robot that can do your laundry, a robot that can move your warehouse items, a robot that can help you with manufacturing tasks. Because if you have one robot that can do all of it, it's gonna provide enormous value. And I believe this is the promise of the general purpose robots. That's why these valuations are so high, because you're about to create a universal form. Meanwhile, the wheeled robots, as I mentioned, they are maybe not fraction of the cost. They are definitely cheaper. You have less problems with them. You have less questions about safety, because with the legged robot, there is a lot of questions. What happens if the battery dies or if there is a power anomaly? Imagine the robot in your house suddenly falls down on, I don't know, your children or your pet or your expensive furniture. This is highly uncontrolled environment, right? I'm not opposing to be fan of this form or this form. I think both of these forms have completely different values to provide. But yeah, when it comes to the legged robots, I think this is the promise of the hype train of creating an ultimate form of a robot that can serve multiple industries at the same time. So that's what I meant
Mhm.
by that.
And you now just mentioned like the safety aspect, and ACTM identifies physical stability as the number one safety concern for humanoids. Yet we still lack a formal ISO standard for dynamically balanced legged robots. So if a 150 pounds humanoid loses power, as you said, and falls near a human or a pet or like really like something that is incredible cruel, it's also a liability nightmare beyond the emotional part. So a wheeled robot just stops. I really want to dig deeper because it, like you said, it's like the hype train. But is the industry then just like hand waving away a fundamental safety flaw to keep the hype cycle alive? And we only care about it afterwards. Or why do you think this is so the case?
So I what I love about technology is the pace. And the pace of technology is typically in 99% of cases faster than the pace of regulations and standardization. We are right now in the era of deploying humanoid robots in the industries, not at scale, mainly pilots, just testing. We are just trying to see robots might be good at. What is the a perfect environment for these? So obviously we have no ISO standard for dynamically balanced legged robots. And I think this is definitely a real gap right now, but we are just getting started. We need to remember 10 years ago, there was also one of the new robot forms introduced to the market, which was collaborative robots, right? Thanks to the Universal Robots, huge success. Also, we need to talk about it more. I think in Europe, that was a European company from Denmark that was acquired for a lot of money a couple of years ago by Teradyne Robotics from US. And they also redefined a little bit of the robotics market, of the robotics arms. Typically, you would have a KUKA, FANUC, or ABB robotics arm that is just welding, moving big boxes, helping you to build cars, helping you to palletize different stuff. But it was fixed, it was pre programmed, and it was caged, right? So it was people couldn't interact with these robots. Suddenly, there is like a shift in the mindset, and you have robots that you can really interact with. But it also took time. Right now, we know we already have some collaborative robot standards, but it took years to do. So I think it's going to be very similar with humanoids. People are already working on these kind of standards, but it will take time. It needs measurements. It needs real data from real deployments. So it will be there for now. I think these robots will be just exclusively working in areas, not with humans, but in a dedicated areas where humans actually and robots cannot be in the same space in the same time.
Yeah, and there is also like this gap, so to say. Like we see these crazy like pictures and videos where you have all these incredible robots, and you think, oh my god, next year I will have an army of robots in front of me. But then it clashes also with reality, what robots actually can do already, and where we still need a lot of research. And so one example that is also exemplary for this is that on in January of this year, in the earnings call, Elon Musk admitted that despite producing thousands of units, no Optimus robots are actually doing useful work yet. They are strictly for data collection, as you also hinted at. So, how do you differentiate between a data collection puppet, so to say, and a machine that is actually providing real industrial ROI?
Yeah, that's a good one. So I think first of all, let's start with the most important part, which is ROI, because this is what manufacturers are looking at, right? Manufacturers are not deploying robots for fun. They're not deploying it for the sake of innovation. They're deploying it because they seek value in the long term. I think right now we are in the phase of validation. What might be like a killer use case for humanoids? What might be the applications that are like providing so much value that we couldn't do it before, or even if we could do it with like standard machines, you can right now do it cheaper. Because I think it's also worth to mention a process that is called retrofitting, which means that you are putting a new technology into really old systems and they can work together suddenly. It means that you do not over integrate these things, you just do it some sort of in a plug and play way. So when it comes to Elon Musk, I believe that we must take any prediction of this guy with a little bit of a pinch of salt, because he is also over promising when it comes to autonomous driving, right? Also, I agree that humanoid robots might be $1 trillion market, because eventually it can solve every single mundane task that we humans are doing, whether it's in our households, whether it's in an industry or in dangerous areas. So I fully agree when it comes to that. When it comes to the value that they can provide right now, I think it's very limited. And I'm not surprised that a lot of industry experts are fighting back against humanoids, claiming that the machines that we have right now in the manufacturing spaces, in the warehouses, they're already super efficient and they are much more efficient than humans. If you think about humanoid, it resembles us, right? People. It has our height, it has two hands, it has five fingers, because it is supposed to retrofit us humans in our daily environments. And my feeling is that maybe if the progress is really fast, we can achieve 100 efficiency of a human. But right now, let's start to think about things like conveyors or dedicating packaging machines. They are much faster than us, right? So they are already much more efficient than humans. Having said that, I think the applications will be limited because there is already a lot of dedicated equipment and machinery that is just faster, more efficient, and more time saving for these companies. Yeah.
I just have one follow up question on that point because I had a conversation with a robotics founder recently who said that, yeah, humanoids might not be the most efficient ones in form or shape, but you need them to build trust because humans understand the shape of humanoids. So, what do you think of that argument?
Yeah, I think it's definitely one of the reasons. I wouldn't say it's the main reason. I would say the main reason might be a humanoid is the form that is going to go exactly into our environment. And if you think about the environment of humans, it's built for humans, right? By humans. So you need a form that will match the same, I don't know, the same spaces. For example, you have boxes that you need to grab with two hands. You have desks that are on a certain height, so you need a form that actually matches that. And if you think about the industrial sites, you have something like brownfield, which is like old sites, and obviously greenfield, right? So in brownfield, everything is fitted for a human. And if you want to deploy new technology, especially very flexible one, it needs to fit one to one. That's why humanoid is such a, I would say, sexy promise, because it just promises that you can replace these humans with robots. And obviously, we do not want to replace humans just for the sake of replacing humans because we are the bad guys. There are some statistics that are speaking themselves for the need of using humanoids. For example, let's put it this way: like the demographics data shows exactly that we are not making enough babies in Europe, especially. There is this famous saying that to have a healthy economy, you would need to have 2.2 baby. per couple. So one per mommy, one per daddy, and zero point 0.2 for the economy. But we don't have that. We are at 1.5-ish on average. In Poland, it's even lower. Yeah, I think this is the trend that is on one side causing that there is not enough labor to work in these sites. And right now, do you think that we are ordering less online? Obviously not, right? We are even ordering more. And so personalization and the perception of getting your package the next day, because 2 days is already a bit too long. So probably I'm going to switch to Amazon because the other provider couldn't deliver within 2 days. We are getting spoiled from the consumptionist point of view. That's why we need to produce more, we need to ship faster, and we have less workers. There is like a bottleneck that we generally need to take care of. And automation and robotics is like a natural answer to that. And I think it's already proved itself, especially in the automotive sector, even 50 years, 56 years ago, right?
Yeah,
Yeah.
I mean, I think we all agree somehow that we have a feeling of where we're headed to also when we look at its demographics and so on. But at the same time, there is still this gap of where how we get there. And in our preparation, we read some really interesting things from the legendary roboticist Rodney Brooks, who calls the current humanoid rush as a pure fantasy thinking, arguing that our hands have 17,000 touch receptors that robots won't match for decades. So, again, do you agree that we're over indexing on the body and ignoring the fact that our dexterity is still, in his words, pathetic?
So first of all, if Rodney's gonna listen to that, big shout out to him. Actually had a great pleasure of meeting him in Santa Clara last year, and he was explaining exactly the same stuff to me. To some degree, I agree, but I'm a techno optimist, and I think that we just require a lot of capital, effort, and dedicated research toward making it less pathetic. Christian, you've mentioned the data collection, right? At some point, I think it's one of the reasons why we are spending so much time, why we are paying so much effort into data collection, because we actually want to solve these problems. We want to have these dexterous robots that are capable of grasping any object or handling any task that you can possibly give to the robots. Meanwhile, I agree. We humans are quite a complicated creatures, right? 17,000 touch receptors and a single hand, and the physical capabilities we have are not that easy to recreate. Although I believe the whole push and the hype that is being created is just towards solving that. So whether you like it or not, this is the mission that right now is being addressed in the robotics industry. Although I agree that the current state of the art of dexterity solutions are not that impressive besides demos. If you see the continuous operations of these robots, you will notice that this is not the level yet that would make, oh, okay, we are there. This is the chat GPT moment for
Mhm.
us. Yeah.
Mhm. And
Um,
you also mentioned or hinted at previous conversations that the near-term winner could also be a hybrid and not just a robot on two legs. So basically, a humanoid upper body for dexterity on a wheeled base for stability, so to say. So why aren't we seeing like this 1 billion rounds for centaurs? Is it just because they don't look as good in the LinkedIn demos that you were just hinting at?
so first of all, I would just start that I'm also very bullish on the specialized robotics companies that doesn't necessarily need to look like humans. For example, companies that are highly specialized, created for solving like a single task and then scaling from them. And I have multiple examples of those. Even some of they are already succeeded. Mainly in logistics, you can see like Norwegian company called AutoStore, right? Or you have French company Exotech. They are doing some sort of big shelves with robots driving there to make sure our packages go to us in time. And they are not humanoids. They are specialized robots to do just one task, but extremely well. When it comes to the centaurs, I would say maybe we do not see 1 billion rounds for them. But for example, company from London that produces humanoids and is also called humanoid is well funded, maybe not by VCs, but they have a founder that is self funding the company at some point, and they want to have a legged robot, but they just start with a wheeled platform because they believe that the first problem they want to handle is hands and is the dexterity and is making sure that the robot provides a lot of value. If you think of the locomotion, it's just the way how the robot moves. The real value comes from really making stuff. So they are tackling that problem just from the other side. I think it's just easier to sell to the investors the form of a general purpose robots. That's why you might seeing this kind of big rounds. But we must remember that raising money is one thing, creating value out of it is another thing, and then exiting and liquidating that company is another. So let's see where it will bring them, because as I said, there is a big promise, but there is a lot to deliver. So let's see.
I want to continue a little bit with this how to make money theme because it's a lot about deployment. And we did have an ETH professor, Roland Ziegler, on the show last year, who made the point that the final 10% of getting a robot to market really takes as much energy as the first 90%. And also, if you look at failure rates or success rates in the lab compared to the real world, you can have a success rate of 95% in the lab and everybody is super excited. But then if you place that to a warehouse where you have daily operations going on, 5% failure rates are actually really high. So it destroys your ROI. So what do you recommend to founders in the community how to really go through this reliability cliff and really move in the long term from a cool demo, which gets a million views on YouTube Shorts or TikTok, to really 99% uptime?
Absolutely. So I would start with a statement that reliability is a product itself. It's not just a feature. This is something you need to strive for. I have a great pleasure also of working for a longer period of time with a company called No Magic from Warsaw. They are doing robot brains for logistics robots. And their kind of mindset is just narrow the task scope until the failure modes are countable. And they are doing a narrow set of tasks extremely well. You can go from 0 to 80%, as you said, very fast. From 80 to 90, maybe a bit slower, but still doable. From 90 to 95, yeah, if you have a handful number of PhDs, probably also you can achieve that. But what really matters, it's how you go from 99.9 into the further digits. Because as you said, if you multiply this percentage, industry operates 24/7 every day. We are sleeping and the production is not. So if you actually multiply these failure rates, it might destroy your ROI. So I would say that it's about narrowing the task scope, really mastering that, and then moving to another task. I see that a lot of companies right now start to focus on so many new things that they do not have the right time to fine tune and to master that right task. Imagine that if you master that one task and it's already on an outstanding level that you can sign an SLA, so the service license agreement with the customer that allows you to generate revenue, it can already start funding you the next endeavors, the next task that you can plug in. But we really need to be focused and exceptionally well on one task, because this is physical world. This is not software that if you make a mistake, people will say, okay, it happens. No, in the real industry, in the real world where you're interacting with real stuff, if it happens, someone loses money, a lot of money. So that's why it's so important to have the right focus on the right task and then to move to another, and not having a big scope of tasks. And they are, each of them is at 80, 90%, because it's not going to work with the industrial people. They are really used to having this 99, if not even almost 100% reliability rate. So again, I will say that treating reliability as a product and not just as a feature. That's how I would frame it here.
Yeah, and we can also see that in the failure rates of robotic startups compared to, let's say, classic software or the average startup ecosystem, they're just significantly higher. And it's just much harder to build a robotics company for several reasons. Deployment is one of them. It's much harder to actually earn cash in the long run. And that also makes it harder to, once you have a funding round, to really get through the cash. So, what do you recommend to founders to, if you look at a long-term strategy for raising money, let's call it, what do you recommend to how to navigate traditional VC timelines?
Yeah, absolutely. I First of all, I would suggest to speaking with VCs that are not exclusively investing into B2B SaaS, because there might be really biased when it comes to outcomes. We know the crazy margins of producing software, and it's very hard to replicate in the world of robots. Hardware is hard. Again, it's really hard. So I would say founders, okay, I don't want to assume that capital these days and the money is commoditized to the degree that you can take it from whoever. Actually, it is commoditized to the degree that if the market is hot enough, like robotics, you could literally raise from anyone. But I strongly advise not to do. I advise to do your own due diligence on the funds. It's not just the privilege of the venture capitalists that can do due diligence on you. You as a founder should be really aware who are you taking money from, because in the end, it's the expectations, it's the smart money, it's the network, and it's everything that comes in a package with the investor. So just make sure that your investor knows what deep tech is, know how much harder it is to iterate on a sheet of metal rather than it is just on a lines of code. So that would be my first advice. Just be really thoughtful of who are you taking the money from, especially at the very early stage, because if the expectations misalignment is really big, you will start having tensions. And if you start having tensions, you do not focus on the product, you focus on managing your investors. You shouldn't manage your investors in the early stage. You should be locked in on building exceptional products. So I would say find those who understand robotics, maybe ex-operators, maybe someone that has funded some companies in the past that had something to do with the hardware, and you will be already one step ahead.
And in software, or now, especially with AI, that theme is emerging that niche is king because it's so hard to build a software business when software itself becomes a commodity. And you've made an interesting point on robotics, saying that sometimes the boring, really constrained use cases are way better than these magic general purpose use cases. And you've pointed to companies like Zipline, who started with medical supplies in Rwanda, or Carbon Robotics, who focused exclusively on laser weeding, like a very specific use case. Can you comment on that? Like, where is it best, or with what mental model is it best to apply this hardware use case in the real world?
Yeah. So I think the boring problems have predictable failure modes too. So you can actually engineer them and you can really focus how to solve them. If you master one task specifically where and you have ROI positive use case, you can already make money out of it. And if you are cash flow positive, it's already a good sign for your startup. So I would say this is one of these things. So even though it's boring, it's actually value providing rather than making tests that are just the promise of the future or melodies of the future. But melody of the future has a significantly lower success rate. It has a definitely bigger risk to reward. But if you want to build a company that is profitable from the beginning, you just start with the boring tasks, you automate them. And I've seen multiple companies that start with these boring tasks, as you mentioned, Zipline, right? So they literally started with just delivering blood samples, I believe, right? Somewhere in Africa. There is another big market. Guess which one? Delivering your groceries. And they have the infrastructure, they have the customer trust, they have already the size of the company that allows them to open another vertical. And this is what I meant by focusing and mastering on one task. And typically it might be boring, but it's not about being boring, it's about the perception of your client. So for example, if he's an industrialist, it might be boring to you, but for example, it's super painful to him. And if you're going to solve it, you earned trust, you earn trust of a client, and you can start building the momentum from them and opening new verticals. So that was exactly how Zipline played it, right? There is another company called Exotech from France. They started with this ASRS. I'm putting this example because they are already a big company, more than 1 billion, maybe even 2 billion valuation. They have like multiple clients all around the world, presence in the US, Asia, and Europe. They started with just making the promise, hey, logistics people, we're gonna give you the package from the big shelves in seconds. And right now they are expanding to different tasks. Hey, logistics people, we've solved that. Give us something harder. What about we gonna right now start to sort out your stuff, which is hard because you need machine vision and you need like this dexterity that we are talking about, but not at the general purpose level, but on something more limited. So that's just my approach to these boring applications that you call them. Yeah.
Do you have a use case in mind or a range of use cases which you think will be really big for robotics in a couple of years, maybe a 5 to 10 year timeline?
Yeah. So first of all, I can also share a very good method how to get these use cases. Typically, when graduates university, he has the mindset of I'm gonna change the world with this because that's my gut feeling, and I'm just gonna start with that idea. My big recommendation is to do a test. We can call it customer development, we can call it customer discovery, and just make a test. Take a piece of paper, write down 10 clients for the vertical you're applying to get in, and arrange a coffee. Hey guys, I would love to talk to you about your problems. I'm gonna be your robotics psychologist. I'm gonna listen to all your pain that you have. And just look at their eyes when they are mentioning all the use cases, and you're gonna notice the one that they struggle to solve for years, and take them as the core problem that you just wanna solve with robots. There is another awesome company. You guys are in Zurich, right? So in Zurich, there is a company called Robotics, which is having this interchangeable tools for cleaning the public spaces like toilets. You would never think of it. It's right now it's teleoperated because they are collecting the data just to make the machine autonomous in some time. So they are playing the game that right now we can teleoperate it, but we can also in the meantime collect data. With the time flow, we actually gonna be able to do it fully autonomously at some time. So this really boring, mundane, maybe not dangerous in this case, but I also wanted to address that there are tasks that are dangerous. For example, guys, imagine for me a big use case. I was selling to oil and gas companies robots, inspection robots. They didn't have back then the gripping or manipulation capabilities. They purely could see because of the cameras, they could smell because of toxic gas sensors. But imagine what happens if you add the dexterity. You could have a robot that can go on a oil rig platforms, these big shaky platforms somewhere in Norway or somewhere close to on the Pacific, and you can have them operate the equipment. Typically, you need to send people up. Actually, that's a use case. If someone from the young founders are listening to that, try to solve that. Because right now, people need to jump on the helicopter. It's super expensive. And the oil and gas companies need to transfer them from the land straight to the oil rig, do some operations, and take them back. It's super cost consuming. So that could be one task. The DDD rule in robotics, the dual, dirty, and dangerous. I would say this is the first layer of the task. So if the task is dirty, dual, or dangerous, I think it's already a good start to automating it. If you add the point I mentioned of auditing your client, and if you merge them together, I think you're gonna have a handful ideas of what you can actually do in robotics to make the world a better place.
One thing that we haven't touched upon yet is because you were saying that in the end robotics, that's not just like you can do a little bit and then see where it goes, because the impact that it has if it doesn't do the right thing can be massive. It's really, I really want to dive a little bit deeper into the training of robotics. And NVIDIA recently launched a platform called Cosmos, which lets robotics companies train their robots inside a simulated virtual world rather than only in the real one. So the promise that they make is that you can generate billions of hours of virtual experience very cheaply instead of running physical robots for years. So, NVIDIA is betting huge on this idea of using synthetic data to bridge the gap between simulation and reality. Now, my question to you is, can we actually simulate our way to, let's say, $1 trillion robotics company, or is there no substitute for the dirty data of real world hardware? What do you think about that?
Yes, it's also a great point. I see so many data collection companies these days and in the data space that it just shows and proves the trends. You need to know that there are a couple of phases where you're using data, and simulation is probably so it's necessary because it helps you at scale, but it's not sufficient. So it's exactly what you've mentioned about the AI capabilities, right? It's easy to go from 0 to 80. So let's take the same analogy with the training, right? You can achieve that with NVIDIA tools, simulation. Then you have maybe some more advanced solutions like physics enabled simulation. So imagine you have a cloth, right? Cloth, it's such a hard to simulate material, or cables or wires. So imagine that you right now also can add some physics characteristics to each of these objects. And it's awesome to help you at the first phase. The second phase, unfortunately, requires the dirty data collection, which means humans really demonstrating and picking different stuff multiple times because we need the depth of the data, and that's just another that and it's hard to scale because you need humans, right? You need human effort, and it's not okay, I'm just gonna have 20 GPUs and I'm gonna simulate it 1,000 times, and at the same moment there's gonna be 1,000 robots. With humans it's very hard to replicate them. I think if we were able to do that, we would be in a different place with our civilization right now. So you need 1,000 humans working in the same time and collecting the same data. So that's, you also mentioned in the beginning, right? Elon Musk is also doing that, the teleoperation, which allows to transfer the human movements to the robot, so the robot can save all the positions of its joints doing these tasks. As I said, it's necessary and it's a huge enabler because it's gonna help you pre-train these models like at scale. But this is not sufficient. That's why you have companies that are making data collection through teleoperation, as I said, so humans controlling robots, but also through egocentric data collections. So human with capture equipment that, for example, are washing the dishes and the camera is just looking what you are doing and labeling the stuff. All right. So in the first second, he took the spoon and brought it to the left hand, and then from left hand he did that, right? And you have systems that are automatically tracking what you are doing with your hands and translating it into the language of the robot. So that's my few cents on the data flywheel, let's say.
Definitely. And I mean, you were mentioning Elon Musk, and I think we don't get away from him because, like, also when it comes to data collection, Tesla's full self driving software has turned every Tesla on the road into a data collection machine. And because of millions of people still driving Teslas daily, the company has now accumulated, and I need to read because it's incredible, 8.4 billion real world miles of driving data. So
Data.
yeah,
That's a lot.
so it's a lot of data for those who don't know how many zeros that has. So consider one of their most valuable assets and potentially also applicable to humanoid robots, not just cars. So for a new robotics founder, is it even possible to build a data mode that can compete with that? Or should they focus on, as we already touched upon, narrow verticals like surgery or agriculture?
Yeah, it's a great question, but I think it's easy to answer because the data that Tesla is collecting is not transferable to robots. Because if you think of Tesla taxis, their biggest objective is not to interact with environment. If it interacts, it means it crashed into something and it's a bad thing. And with robots, it's completely the opposite. The only task that the robot should do is to interact with the environment. So the data that the Teslas are collecting are not super helpful for robots. Maybe to some degree for some, I don't know, last mile deliveries, robots. You have another shout out to Marco Bielonic from Zurich as well, and River. I'm just wondering if you can just look behind your window and see a robot dog driving your food. That's so cool. Maybe to these, but not for the dexterity manipulation level, but just for the locomotion, maybe the navigation stack. I would say there is a lot of room to beat Tesla on that because they are. I would say this is a completely different data collection market, and Elon is collecting a lot of data for humanoids, not through the Tesla's cars, but through the teleoperation, as he was showing plenty of times. So definitely, don't be afraid to compete with the biggest ones. Definitely not. There is still space, and you
That's the
should have
spirit.
appetite to take it. Yeah.
And we've mentioned Tesla, which is obviously a US firm. You mentioned a lot of European firms. We have here in Zurich a super huge ecosystem in robotics. There is also China. And in this global race, I think China, especially, we also looked that up, is committing 100 billion US dollars to robotics. And they are pretty huge in pushing the humanoid market in terms of unit volumes. Like, where do you see Europe positioned there in that global race?
Yeah. So we just need to look at our matrix of competences. What are we best at? I think we are really great at building excellent hardware. We are really great when it comes to universities, which is talent density. And I think we are proving that also by shipping the hottest talent to the US. We also need to understand why it happens. It's also about the regulatory work when it comes to incubating startups. Fortunately, we have people like one of your guests that were on this podcast, like Andy, who is working with a lot of people engaged and involved in the EU Inc., which promises to simplify setting up the companies, to simplify raising money, to simplify spending the raised money, and simplify to be able to build pan-European teams. So we do not miss anything from the technical resources. talent, not even capital. It's just the setup of the company is so much more effective in the US. That's why people decide to go there. And I do not want to be like that the Europe is going to be the digital colony. That's why I'm super obsessed about the European founders actually building here in Europe. And it doesn't matter if there is a bridge and they have some talents in SF, we should leverage them because SF, Boston, Shenzhen, these are great places to build. But we need to make sure that Europe is in the loop, not outside. And I think it's happening more and more. Also, cheers to a friend of mine, Pavel Bujanowski, who was the ex-co-founder of the KSK Labs. That was probably the only US company that shipped humanoids back in the days. And right now he's building it straight from Warsaw, between Warsaw and Redwood City. It's called Loot One. And he's bringing humanoid robots into retail for restocking stuff. And then he wants to expand to different verticals. So we have everything what we need. But as I said, the how to say it, the conservative approach to venture to risk is just not helping us out to starting these new endeavors. But it's not the fault of the talent or of the tech stack. It's just something that must be changed, and EU Inc. actually addresses that. So I think it's also in safe hands. Fingers crossed that it's going to be resolved as quickly as possible so we can start building more companies here in Europe originally.
Yeah,
Yes.
and I mean we also have the manufacturing base, so the clients. I think you mentioned that in your newsletter recently that BMW actually announced or made it public that they are deploying now the first humanoid robot somewhere in their factories.
Yes, in Leipzig, in Germany, they have deployed the Hexagon Robotics, which is based in Zurich, as far as I know, too. And
Anyone listening, Zurich is a great place to be.
yeah, in one of my posts, I put a headline: "Is Zurich the European San Francisco of robotics?" I was roasted a little bit that we do not need to compare ourselves. Just to clarify, it was just a clickbait, so more people read that. Obviously, I'm not comparing it directly. I just have a feeling that Zurich is such a great place to build robots these days, and there is so many robotics companies that it just compounds naturally.
Yeah, and maybe one of the last questions directly on the point. If you're now 25-year-old student or PhD or aspiring PhD or whatever in robotics, you're here in Europe, with all the strengths and weaknesses we have, like why should I stay in Munich or Zurich or Warsaw or some other European city instead of moving to the US?
Good question. I think the best reason to stay is definitely that if your target customer is for example, a European client, a European manufacturer, a European supply chain client, then you just need to be close to them. My actual advice would be to spend like 6 to 12 months in San Francisco to build the network, to learn, and then decide with the full information where to start. It's the Chinese approach, right? A lot of students from China go to the US, learn their craft, build a network, go back to China, and build at the full steam ahead. Why not to do the same in Europe? Honest answer, if your goal is to build like a $10 billion company right now, San Francisco probably gives you like a 3, 5-ish year advantage, like a head start. But we have the real advantages, like definitely lower burn, like really deep industrial access, maybe less competition for the talent yet because it's not so dense. And by the way, just wanted to mention that even technology needs a break sometimes, and my lamp is just already giving me signs that it's weekend. Sorry for that. So yeah, there are a couple of cool places like Munich because of the university and because of the real capital that is also in that city and the deep tech and industrial heritage. Not mentioning Zurich. Cool place to build is also counterintuitively Odense in Denmark because a lot of successful IPOs and a lot of successful actually acquirers come from Denmark. So they have the capital and they have the robotics mafias that are willing to fund the next winners. So that's one of the spots in Europe that you might be really looking at if you want to start a robotics company. I also wanted to mention place in Poland, which is Warsaw. We have at least two great universities. One of them is based in Posen, in Poznan. This is like a heritage of mechanical engineering, and obviously, when it comes to AI, it's Warsaw. And I see like Warsaw is becoming the hub in Central Europe of the AI, and there is a lot of talent. There is a lot of VCs. There is a lot of events right now, and a lot of crossovers between San Francisco and Warsaw. So I would definitely advise also Warsaw as
Uh,
one of these places to build. Yeah.
I can only agree with that because that would be also before we head into the rapid fire questions, like one observation because I co-initiated the Relativity Collective Pan-European founder community connecting the continent's best early stage talent. And we've received so many applications from Polish students, incredible talented, very technical, like in the robotic space. Like I was incredible surprised also, and at the same time I realized that I know very little about Poland, and I'd really like to know a little bit more about the ecosystem and why I'm probably not the only one that has underestimated this kind of part of the European continent.
First of all, is massively underestimated
Yeah,
and people don't know it yet. So I think as in business, it's always very good to know things
yeah,
earlier than the market.
100%.
First of all, I think we have a very strong engineering culture and world-class technical universities. And I would say we also have the willingness to prove something and the hunger. We have the hunger to conquer the technical space with the resources I just mentioned. As I said, Warsaw, Wrocław, Krakow, Poznan, and Gdańsk, they are producing serious talent, and you can see the migration patterns from these universities to the US, to the other European cities. So if you extrapolate these talent and if you create a scenario when they are not moving and they are staying, then it's really about to get really serious. I would say I'm not gonna be just bullish on it. I need to also say there are some hiccups. For example, the gap is commercial, right?
Mm.
Like they are like Polish founders build well, but they'll sell conservatively. I would say those that go to the US, maybe they learned that the hustle skill, hustle muscles. But yeah, we tend to be very shy. We tend to underestimate ourselves. But I think success stories of building outstandingly successful companies, like for example, 11 Labs, right?
Exactly.
So valued at 11 billions, right? Founders are here from Poland, and they moved, but actually there was a lot of angels and early funds like Credo Ventures, for example, that funded it very early. I think it's going to help to build the momentum and the credibility of these funds, of these founders, of the region in general, that it's just going to attract more talent or cause that not so much talent will just explode outside of the world and they will just decide to stay. I would say that Poland is where Germany was like 15 years ago when it comes to deep tech, but the next wave is just forming right now. We do not have so much experience when it comes to venture capitalism, right? It just started getting serious maybe 10, 15-ish years ago, not like 25 or 30 like in Germany or 70 like in United States. I think the chances are raising, and this is where I'm super excited about. So the VC space is growing. We are learning how to back these founders. These founders are learning how to sell outside of Europe, how to sell globally.
Mhm.
And I think it's definitely one wants to watch when it comes to regions.
100%. So we are getting to the rapid fire questions. One question, and just like in very short sentences, what you think, comes to your mind. So, first one, when a founder shows you a mind blowing robot demo at the trade show, what is the first question you ask to see if they're actually ready for production?
Humanoid, what happens when it falls? Not humanoid. Can you show me the Excel showing how it benchmarks with the previous solution, whether human based or old generation automation based?
What is one thing everyone in physical AI believes right now that you think is completely wrong?
Okay, very contrarian thought, but that the hardware problem is mostly solved, and I think it isn't, and we just gotten better at hiding it, and I think we will come up with really new breakthroughs in that area too. In software, obviously, as well, because everyone talks that we need to have better software because hardware is already solved. Companies like Alonic from Hungary, they just introduced a 3D braiding machine. So you are like printing new parts, end to end actuators. I think that hardware problem is mostly solved. This is one thing that people might have wrong. Yes.
And maybe close to that, you publish to over 100 million people a year. What's the robotics narrative you've had to actively fight hardest to not amplify because the hype was dangerous?
Oh, it's easy. As robots will take my job. It's always like this. It's shifting right now a little bit. I'm not gonna talk to you because robots gonna take my job. Right now, people are like looking at the door. Okay, maybe we should talk again. Maybe I start having problems. Logistics people have these peaks, right? You have Friday, you have Christmas, and they need people, and the people are coming for 1 month. They are coming for 2 weeks. They are not showing up to work. They are taking sick leaves. You cannot control your workforce, but you need to control your order and the demand. They are starting noticing that it's not about actually job displacement. It's literally just about having a steady and repeatable solution that can help your business to survive hard times. And COVID was the right time to prove everyone that automation is actually there to help us, not to steal someone's jobs.
If you could just invest into one robotics company right now, what would it be?
I don't know if I want to really shield someone.
Favorite.
Okay, I would invest in my own media agencies. More people know about robots and they are more educated and they are not scared and they just know the benefits. So I would invest in the education of humanity for robots. So they are prepared when they are here already. Yeah.
Perfect answer. Lukas, I thank you very much for this talk. That really was a pleasure. If people want to learn more about you and your work, where can they find you?
So I'm active on LinkedIn under Lukas M. Ziegler. I'm active on Twitter under Lukas M. Ziegler. And I also have 2 newsletters with more than 100,000 subscribers, which is called We All Are Robots. Such a contrarian take. And yeah, that's where they can find me. I'm always happy to talk to people about robots. I'm very enthusiastic about robotics. And I'm very happy if I turn one guy that doesn't believe in robotics, that robots actually gonna provide a lot of value in the future. So I'm ready to be a sparring partner for robotics for anyone.
Thank you so much for being on the show. We really appreciated it. And yeah, I'm already excited to talk to you again about the next wave of robots.
Thank you so much, guys, for inviting me. And so sorry for the technical problems. I think it's a great analogy to that technology is there, but we still need to fine tune it. And it's really
Absolutely, 100%.
It is. Thank you very much.
Thank
Bye.
you.
Bye. And this was another episode of our Follow the Gradient podcast.
And now we would love to hear from you. How did you like it? What should we improve? Do you have any suggestions, ideas, or dream podcast guests? Please let us know.
Thank you and see you again next week.